Hello students, today we are going to solve chemical kinetics questions from JEE question paper, and this test was held on 10/6/2023. Now let us begin with solving chemical kinetics questions. So here is our first question. So they are giving here the following is the graph between log T half and log A for a given reaction at 27 degrees Celsius. Hence, order of the reactions. So using the graph information, we are now going to determine the order of the reaction. Okay. Now let us begin with the question. So how to approach? Basically, here it is. That is the graph is given between log T half as well as log A. Correct? So which means that we know the T half of nth order reaction. So it is directly proportional to A raised to the power 1 minus n. Okay. Now, in order to remove the proportionality constant, now we will be writing T half is equal to K A is raised to the power 1 minus n once again. Okay. Now applying log on both the sides. So when you apply log on both the sides, it will become log T half is equal to log K plus log A power 1 minus n. Now we know that this will become log T half is equal to log K plus 1 minus n log A. Okay, log A. And now this is almost obeying line regression formula like this. So you can assume y is equal to mx plus c like this. So which means that m is the slope. So from the equation, you are getting the slope value to be 1 minus n. And now from the graph, here they have given theta, that is, tan theta. So tan 45 from the slope value is tan theta, which is equal to 45 degrees, which is also equal to 1. Now equating the graph value, that is tan 45 is equal to 1, and similarly from the formula it is 1 minus n. So these two are, when we are equating, that is 1 minus n is equal to 1, n will become 0. So hence the order of the reaction is 0 order. So option A is correct. Okay. Now coming to the next question. So here what they are asking, so they are asking decomposition of H2O2 follows a first order reaction. So fine. Now next is what? They are giving the time 50 minutes, and then the concentration of H2O2 decreases from 0.5 to 0.125 m they are giving. And finally they are asking, when the concentration of H2O2 reaches 0.05 molar, the rate of formation of O2 will be. So which means that this question involves 3 steps. So which are the 3 steps? Now first of all, let us understand how 3 steps. First of all, they have given that H2O2 is decreasing from 0.55 to 0.125, which means that we need to determine K here. So once K is determined, that is rate constant of a first order reaction is determined, then you will be able to determine what will be the concentration of what will be the rate of formation of H2O2 when concentration is this 0.05. Okay. And third step is, after calculating the rate for the formation of H2O2, we will be also determining how much formation of O2 is obtained. That is, rate of formation of O2 is obtained. Okay. Now let us take up the first step. So what is the first step? First step is nothing but determination of K value. So let us begin. So K is equal to 2.303 divided by T log A naught by A. Substituting these values, you will get K is equal to 2.303 divided by time is given, that is 50 minutes, log of concentration of 0.5 divided by 0.125. Okay, now how much would be this value if you simplify this? So this would be equal to, let me write, which is equal to, if you simplify 2.303 by 50, you will get a value of 0. How much? 0.4606, and this will become log 4. Now we know how to write log 4. So how will you write log 4? So log 4 can be written as 2 power 2. So that becomes 0.04606, then into 2 log 2 you can write. So on simplification of this, the K value is determined to be 0.02. 1 second, students. So basically this value will be equal to product of 0.02769 minute inverse you will get. Minute inverse. So first step is done. Then what we have to do? We need to do the second step. What is the second step? Since K is defined, K is determined, you have to just give the rate. So what is rate? How will you give rate? So rate is equal to K into concentration of H2O2, correct? Now what is the value of K? K is 0.02769, and concentration they have given in the question, it is 0.05 molar, right? So which means that rate will become equal to how much? Rate will become equal to 1.384 into 10 power minus 3 mole per liter per second. Okay, mole per liter per second. So this is what you will get. So after this, what we are supposed to determine, we have to determine the rate of formation of O2. So for that, we will write the balanced chemical equation, that is decomposition of H2O2. So how H2O2 will be decomposed? So 1 mole of H2O2, when it is subjected to decomposition, there is formation of H2O and half mole of O2. Half mole of O2. Okay. Now we know the rate of formation of H2O2. So that need to be equated to rate of formation of O2, right? So we know how to write the differential rate equation, which means that d of H2O2 divided by dt is equal to, basically we will write for stoichiometric coefficient, if it is 2, then 1 by 2 of any concentration term we will write, but here it is 2 directly, that is half directly, and hence it becomes 2 of dO2 by dt. Okay, now what is the value of formation of H2O2? So formation of H2O2 is 1.384 into 10 power minus 3 mole per liter per second. So now we need to determine only for oxygen, right? So how do you do? So it becomes, let me write, d of O2 by dt will be equal to this value, then divided by 2. So when you simplify this, you get a value which is nothing but 6.93 into 10 power minus 4, okay, mole per minute. So which option is correct? Mole per minute. So which option is correct, students? So option D is correct. Okay, now let us take up the next question. Okay, next question. The rate constant, the activation energy, and the Arrhenius parameter of chemical reaction at 25 R, they are given respectively. The value of rate constant as T is infinity. Okay, as T is tends to infinity, then what will be the rate constant they are asking, isn't it? What will be the rate constant value? So we will do this question quickly. So 1 second. We know the Arrhenius equation. So what is Arrhenius equation, students? So that is K is equal to A into e to the power minus A by RT. Okay. What they have given? So they have given the value of A. So how much is the value of A? How much is the value of A? Value of rate constant is this much. Activation energy is 104.4 kilojoules per mole, and Arrhenius parameter is this. So now we are going to substitute the value of A. So when you are substituting the value of A, it will become 6 into 10 power 14 into EA by RT. Okay. Now what will happen basically? So they are telling that T is infinity. So when T is infinity, this whole term will become equal to what? 1. Why it will become equal to 1? Because when T is infinity, this term, that is EA by RT, will become 0. E power 0 is equal to 1, and hence K will become equal to, so K will become equal to the value 6 into 10 power 14 as the value, that is second inverse, and hence the correct option is option B. Option B is correct. Okay, now let us take up the next question. So what is the next question, students? So it is based on the activation energy. Okay, they have given the hypothetical reaction here, and they are also giving delta H in terms of negative. So whenever delta H value is given in negative, it is understood that the reaction is exothermic. The energy of activation of backward reaction, so backward reaction is given as 20 kilocalories per mole. In the presence of the catalyst, the energy of activation of forward reaction, which means that we need to assume two different types of curves here. One is in the presence of the catalyst and one in the absence of the catalyst. And both of them, we need to show it as exothermic because based on the value of delta H. And at 400 Kelvin, the catalyst causes the rate of the forward reaction to increase by the number of times equal to. Okay, now let us solve this question. Question number 34. Okay, so let us first draw the graph. So once graph is drawn, from there we will be able to understand clearly what exactly we are doing. Okay, now first of all, let us make the graph. Okay. Now, how do we draw the graph? Okay. Now, one more curve we need to draw now as dotted lines because we want to show two curves, right? So, how do we show? Okay. Now, what they have given. So, now we all of us know that this is potential energy, and this is reaction coordinate. Okay. Now, we will write whatever the information that is being given. So delta H is 15. Delta H is 15. So what is delta H basically? The difference in the energy between the reactant, because this is A, reactant A, okay? This is reactant A, and now here, this is what is the products, okay? This is what is the products. Now what we need to write? The difference between the energies of reactants as well as products is what is called delta H. So this is what is called delta H. What is the value given? 15. Okay. Kilocalories. 15 kilocalories has been given. After that, what information they have given? The energy of activation of backward reaction is 20. So energy of activation of backward reaction means how much from the peak. So this is the activation energy of a backward reaction. So it can be written as what? EA, F of EAB, okay, EA, activation energy of backward reaction, which is nothing but 20 kilocalories. Okay. Now what they're asking? In the presence of catalyst, the energy of activation of forward is 3 kilocalories. So which means that before the catalyst, how much it would be? So forward. So how much from this peak? So this is nothing but from here it would be 5. So activation energy of a forward reaction, it will be 5 kilocalories per mole. Correct? No. Now it is understood that in case of using the catalyst, the activation energy is becoming 3. So which means that the activation energy is being decreased. Correct? Now accordingly, we have to make two different equations from the Arrhenius equation. Let us make K1. So I'm assuming K1 is equal to EA by RT, and this one I will be assuming EA1, and similarly K2 I will write K2 is equal to A e to the power minus EA2 by RT. Okay. Now what are these reactions equations? So this is without catalyst. This is without catalyst. And second one is with the catalyst. Second one is with catalyst. Okay. Now what we are trying to determine? We are trying to determine the ratio of K2 by K1. Okay. Now, so how do we write it? So K2 by K1 will be equal to A, and A gets cancelled. Then it will become what? E to the power minus EA1 by RT divided by E to the power minus EA2 by RT. Okay. Now the same thing can be simplified as K2 by K1 is equal to E to the power EA2 minus EA1, okay, by divided by RT. Okay. Now we know what is the activation energy of EA2. EA2 is with catalyst. With catalyst, the forward is becoming less. So that is 3. And EA1 we have determined. EA1, which is to be 5 kilocalories per mole. And substituting those values, you get the answer. So what will we do now here? So which is equal to E power. EA2 is how much? So 5 minus 3 divided by, so kilocalories means R value need to be taken as 1.8 or otherwise 2, you can round it off, and then 2 into temperature they have given in the question. How much is the temperature? So temperature is 400 Kelvin. So substitute the value of T. So that will become 400 Kelvin. So if you simplify this, you get E to the power 2.5. 2.5. Okay. So hence, the value will become E to the power 2.5. Which option is correct, students? Option B is correct. So what did we do here? Quickly. So we are trying to determine based on delta H value as well as activation energy of a backward reaction. Basing on this forward reaction, activation energy is determined. Once this is determined, we are taking the activation energy of this 5 value as well as activation energy of the catalyst catalyzed reaction is 3 kilocalories per mole. In such case, at 400 degree Kelvin, what will be the increase? That is, increase the forward reaction, how much it will increase is the question. So that forward reaction will increase by E power 2.5. Okay, hope you understood this. Now let us take the next question. So once again, this is based on activation energy only. So hypothetical reaction has been given. So what is the hypothetical reaction? A to B, they are giving. The activation energy for a forward and backward reactions are 19 and 9, they are saying. What is the heat of the reaction, they are asking. What is the heat of the reaction? Okay. So forward and backward reaction activation energies are being given here. Okay. Now we know the formula. So what is the formula? Formula is nothing but delta H is equal to EAF minus EAB. So what is the forward? So forward is being given as 19 minus 9, which is equal to 10 kilojoules per mole, not inverse, per mole, or otherwise indirectly, right? So option C is correct. Okay. Next, coming to the next question. So that is 36th question, right? Fine, then let us understand what is this question. At the point of intersection of two curves shown, calculate the concentration of B in the first order reaction. And this is the hypothetical equation. So which means that we need to determine the stoichiometric coefficient of B. So stoichiometric coefficient of B need to be determined. Okay. Now we will assume whenever a reaction we have, that is a chemical kinetics. So we will write A is giving rise to NB means when time T is equal to 0, T is equal to 0, concentration of A will be A. When time T is equal to T, here there will be formation of X moles of product B. And since here stoichiometry need to be determined, it will be NX. Okay. Now how much will be the reactant at time T? So it will be equal to A minus X. A minus X. Now from the graph it is evident that, can you see here the point of intersection between, this is the product curve. So this is the product curve and this is the reactant curve. So when time T is equal to Ta, the concentration of B is becoming equal to concentration of A. So which means that A minus X is equal to N minus X. Sorry, Nx. A minus X is equal to Nx from the graph, right? So which means that we will be equating A minus X A minus X is equal to NX. Okay, bring the like terms on the same side. So how do we bring the like terms on the same side? So which means that A will become equal to NX plus X. Now take out the common, which is nothing but which is common basically here. Common is nothing but X is common. So if you take out X, N plus 1. So now X is equal to, what is the value? A divided by N plus 1. So now substituting the value of X here, then it will become what? N into A. So final answer is coming out to be what? N moles of A by N plus 1. So now which option is correct according to the solution? So according to the solution, option C is correct. So hence this is the correct answer for 36. So which means that we are comparing from this step as well as from the graph, and it is assumed that concentration of A is equal to concentration of B, on basing on which we are getting the value. Now coming to the 37th question. So what is 37th question? For the two gaseous reactions, following data is given. So A to B, so what is happening? A to B, they are giving K1 value, and C to D, they are once again giving K2 value. Okay, now what they are saying, the temperature at which K1 becomes equal to K2. So which means that we are now going to equate these two terms, which means that we need to find out at which temperature both K1 and K2 will become equal to each other. Okay. Now, how do we do it? So it is quite simple. So which means that we will be just equating both the Arrhenius equations, that is 10 power 10 e power minus 20,000 by T is equal to 10 power 12 e to the power minus 24,606 divided by T. Okay, so bringing the same terms, okay, on the same side. Now what will I do? So I will be taking this 10 power 10 side, so that this value will be here, okay, down in the denominator. So now accordingly, I will write 10 power 12 divided by 10 power 10, which is equal to how much? So e power minus 20,000 by T divided by e power minus 24,606 by T. So now on simplification of this, we will get 10 power 2. We will get 10 power 2 is equal to e to the power 24,606 minus 20,000. T is common. T is common, which means that divided by T. Okay. Now what it will become? The difference will become equal to how much? So the difference will become equal to 10 power 2 is equal to e power 4606 divided by T. Okay. Now applying log on both the sides. So when you apply log on both the sides, you will get 2 log 10 is equal to 4606 by T. Okay. So how much is 2 log 10? So which is nothing but, so log 10 is equal to 1, and it will become 1. So 2 into 1. So now we require temperature, at which temperature both K1 and K2 will be equal. So which means that 46, when you are applying, we will also get the value, that is 2.303. So here we have to also write 2.303 T. So now on doing the simplification, 4606 divided by 2.303 into 2. So final answer will be T will be equal to how much? So T will be equal to 1000 kelvins. 1000 kelvins. So where is the answer? So option B is the correct option. Okay. Now we will check for other chemical kinetic questions. Yes, here we have 45th question. So what is 45th question, students? See, a reaction takes place in 3 steps. The rate constants K1, K2 and K3. The overall rate constant K is equal to K1, K3 by K2 they are given. If E1 and E2, E3 corresponds to the activation energies of the 3 steps, respectively, the overall energy of activation. It is quite simple. Based on the overall rate constant K itself, we will be able to understand that K1 is product of K1 and into K3 we are doing, which means that the values of activation energy of the first reaction and third reaction will be taken as summation and subtracting K2 value, by subtracting K2 value. So now what is the K1 value? So K1 value is 60 and K3 value is 10. So 60 plus 10, 60 plus 10 is 70, 70 minus 30 is 40. So option A is correct. So option A is correct. Okay. So how did I do this? So I'm doing summation of 60 plus 30 minus 10. So which is equal to, I'm sorry, 60 plus 10. 1 second. 60 plus 10 and minus 30. Okay. Because we are adding the first reaction as well as third reaction, which is nothing but 10, and here it will be subtracting the second energy and hence it will be 40. Okay. Yes, next question is question number 55. What they are asking? So the half-life period of a radioactive element 40 days they are giving, and if 32 grams of the element is stored, which means that the initial concentration for 160 days, okay, time they are giving total time, calculate the weight of the element that would remain in grams. So here we have a formula. So what is that formula? What is that formula? So formula is nothing but AT is equal to AT is equal to A naught into 1 by 2 raised to the power n. We know what is n. So n is equal to total time divided by t half. Divided by t half. So what is the total time that has been given? So 160 days. 160 days divided by 40. So which is equal to how much? 4. Which is equal to 4. Now substituting all the values of AT and A naught, what has been given? So A naught is been given. So A naught is how much? So A naught is equal to 32 grams into 1 by 2 raised to the power 4, which is equal to 2 grams. Which is equal to 2 grams. So this is the answer for 55th question. Now we will be doing it for 56th question. So what is 56th question? The energy of activation for a reversible reaction is 6 kilocalories and heat of reaction is minus 3 kilocalories. The energy of activation for backward reaction in kilocalories they are asking, right? So how will we do? So this is once again simple. So now we need to make a graph. Okay. So whenever heat of reaction, that is delta H value, is given in negative, it is understood that it is exothermic reaction. Now let us make the graph. So we all of us know this is what reaction coordinate. Reaction coordinates and this is your energy. And now we are saying it is an exothermic, which means that the product's energy will be higher than, reactant's energy will be higher than the product's energy. Now what they have given? So they have given delta H value. What is the delta H value? So this is the delta H value. So this delta H value is given to be 3 kilocalories. Okay. And now the activation for reversible reaction is 668. So which means that activation energy for a reversible reaction is from the product to reactant. So which means that this is what is the energy of activation for a reversible reaction is 6 kilo forward. So forward is this much. So I'm sorry. So forward they are giving. So this is 6 kilocalories. This is 6 kilocalories, which means that they are asking activation energy of a backbone. So hence it will become 6 plus 3. So it will become 6 plus 3, which is equal to 9 kilocalories of the activation energy, which is equal to EAB, activation energy of a backward reaction. Now find next question. So what is the next question? The unit of rate constant is being given. What is the rate constant that they have given? This is liter square mole minus 2 time inverse, the order of the reaction. So order of the reaction is 3. Why order of the reaction is 3? Because we know the rate constant of a nth order reaction, rate constant units. Okay, rate constant units for nth order reaction. So how do you write basically? So this is nothing but mole by liter, that is mole per liter expresses concentration, and which will have the formula that is powers as 1 minus n and then time inverse, right? So in order to get liter square and mole minus 2, then definitely n must be 3. So order of the reaction is 3. Okay, next question. So what is the next question? So here the gas phase decomposition of dimethyl ether, and they are saying that this reaction follows first order kinetics. Okay, the reaction is carried out in constant volume container at 500 degrees centigrade and has half-life of 14.5 minutes. Initially, only dimethyl ether is present at a pressure of, andre initial pressure they are giving it to be 0.40 atmosphere. The total pressure of the system after 12 minutes is, they are giving x by 100 and find the value of x. Okay, fine. See, basically whenever we are doing, first order kinetics, especially the gaseous reactions. So how do we do? So even though we know the formula, what is the formula of first order reaction? We know that K is equal to 2.303 by T log of Pi minus X. This Pi minus X will depend on the number of products that are obtained, number of products, and then their stoichiometry and reactant stoichiometry, everything, isn't it? So hence we need to determine what is this Pi minus X from the reaction given. So instead of taking the dimethyl ether, I just take it as ABC because all the products are in gaseous state, and we will determine what is this Pi minus X. Once this Pi minus X is determined, we will be able to determine it directly. And one more hint here, what they have given is, they have not given the time here, they have given the T half. That is T half is nothing but half-life period. Using the half-life period, we will be determining what is the K, what is the value of K. Okay, now we will try to solve it. Okay. Fine, students. Now let us begin. So we will take the hypothetical reaction here as where A is giving rise to B plus C plus D. Okay. Now when time t is equal to 0, when time t is equal to 0, what will be the concentration? That is initial pressure Pi. When time t is equal to T. Okay. So what will happen basically here? X moles of B is formed, X moles of C is formed, and X moles of D is also formed, and hence initial concentration will decrease as Pi minus X. Now basically we also will determine one more thing, which is nothing but total pressure of the system when time is T. So that will be written as PT. So how much will be the PT? So the summation of all these things. So Pi minus X, 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 X. So which means that it will become how much? Pi plus 2X. So it will become here Pi plus 2X. Okay. Now what will be the X value? So X value will be PT minus Pi divided by 2. Okay. Now applying X value basically in Pi minus X, we will be getting the value of Pi minus X. Okay. So now what shall we do is we will take up the first order kinetic equation and we will try to solve it. Okay. So now what we have to do? So let us segregate this information. So now we will try to solve. Okay. Now we are going to take, instead of writing, here K is equal to, I'm taking it as KT divided by 2.303 log Pi by Pi minus X. In that way I'm going to take. So which means that KT divided by 2.303 is equal to, we know the value will become log of Pi minus Pi minus 6. Okay. Now we have determined K value. So how can we determine K value? So K value can be determined. So here 0.693 divided by T half they have given, that is 14.5. So this value comes out to be 0.0478. Now substituting these values here, we will be getting the value of log Pi minus X is equal to K value is how much? 0.0478 and time they have given that to be 12 divided by 2.303. So which is equal to, if you simplify, it comes out to be 0.249. So this value only they have given it to be 10 power 0.25. So which means that Pi divided by Pi minus X will be equal to 10 power 0.25. So which means that the value of Pi divided by Pi minus X is equal to 1.778. Now substituting what is Pi given in the question, that is 0.40 atmosphere, and what we will get in terms of the denominator, that is the total pressure of the system at time t is equal to t, that is Pi minus X by substituting the X value. So here is the X value. X value is nothing but Pt minus Pi divided by 2. Correct? So now after substituting this, we will be getting the value, and let us do systematically. So how do we do systematically? So which means that now I'm going to substitute this X value in this Pi minus X. So basically what do we get? I'll do it here. So Pi minus PT minus PI divided by 2. So on simplification of this, basically you will get it as 3 pi minus PT divided by 2. So now substituting this entire value in this expression. So it will become what? It will become 2 will go to the numerator and hence it will become how much? So I will write 2 pi divided by 3 pi minus pt. Now we know what is the value of 2 pi. So 2 pi will be, that is pi will be 2 into 0.40 divided by how much? 3 into 0.40 minus PT. So how much is the PT? So PT is basically x by 100 and this is equal to 1.778. Okay, on simplification of this, you will be getting something like this, comma, where 0.80, okay, divided by 120, that is into 100 minus x, which is equal to 1.778. So finally, we will be getting, an expression where x is equal to, entire simplification, you will get 133.36 divided by minus 1.778, which is equal to 75.0056. So which means that you can consider x value to be 75. So this is what is the solution that you have to do it for 58th question. Hope you understood it, and if you have any doubts, you can approach me during the class hours. So now let us take up the next question. What is the next question? At 407 Kelvin, the rate constant of the chemical reaction is 9.5 into 10 power minus 5 second inverse. And at 420 Kelvin, the rate constant is this. The frequency factor of the reaction is x into 10 power 5 second inverse. The value of x is, report your answer by rounding it off to the nearest whole number. Okay, fine. Basically, we need to determine something called, what is it? X value of the Arrhenius, or what do we say, pre-exponential factor. So let us define it. So once again, we will start with the Arrhenius equation. So Arrhenius equation, K1 and K2 values are being given. So if K1 and K2 values are given, we know the formula. So directly write the formula. So what is the formula? So log K1 log K2 by K1 is equal to, okay, EA by EA by 2.303 R T2 minus T T2 minus T1 divided by T1 into T2. Okay. Now substituting the values. So what are the values that are being given? So look at this. So this is the rate constant, that is K1, and K2 are being given. So K2 are being given. Now substituting K2 value. So what is the K2 value? K2 value is 1.9 into 10 power minus 4 second inverse, and K1 value is 9.5 into 10 power minus 5 second inverse, and T2 is 420 kelvins and T1 is 407 kelvin. Substituting all the values, we will be getting where log 1.9 into 10 power minus 4 divided by 9.5 into 10 power minus 5 is equal to activation energy we are actually determining. So which means that A divided by 2.303 into the universal gas constant value 8.314 multiplied by 420 minus 407 divided by 407 into 420. Okay, so now we will simplify this. So when you are simplifying this, what will you get? Basically you will get log 5. So you will get log 5 which is equal to A by 19.147 into 13 divided by into the difference is 13 divided by the value of 170.1770940. So now on simplification, we know log 5 is equal to 0.69. So finally, you will get a value of 1 second, students. You will get a value of I'm sorry, here log 1 by 5 you will get because 19 5s are allowed. Okay, 1 second. Otherwise I can write 10 by 5 which is equal to log 2. So log 2 value is 0.3010 into 19.147. Okay, divided by basically this value you will get it as 0.00076 approximately. Activation energy will be equal to 75,832 kilo, that is joules you will get, and if it is converted then it will become 75.83 kilojoules. Okay, so this is the activation energy that you will get. After this we have to calculate what we have to determine what is the value of the Arrhenius constant in which x value, correct? So what we have to do, once again we have to take the formula, that is K is equal to A e to the power minus A minus A by RT. Okay, what is the value of K? Anything you can take among these two. So here I have taken the value of 1.9. So hence I will apply log on both the sides. So if you are applying log on both the sides, you will get log K is equal to log A minus A by 2.303 RT. Okay, now log of 1.9 into 10 power minus 4 is equal to log A. How much they have given? They have given x into 10 power 5. So x into 10 power 5 minus A value is how much? So we will be taking 75,832 divided by, we know, 2.303 into 8.314 into the temperature given. So which temperature? So since we are taking the rate constant K1 here, sorry, K2 here, we will be taking 420 as the temperature. So as the temperature, that is 420. So on simplifying this, how much do you get? So x into 10 power 5, that is x into 10 power 5 will be equal to 9.4297 minus 4.3020, and finally x value, if you simplify this, you will get 5.1297, and hence x value can be rounded off to the value 5. Okay, so here log 1.9 into 10 power minus 4 is taken as log 2 plus minus 4 log 10, and that is the reason we are getting minus 4.3020. On simplification of this huge number, you are getting 9.4297, and now subtracting these two, we are getting x value to be this, and on rounding off, the x value is becoming 5. Okay, now the last question of this session. An organic compound undergoes first order decomposition. The time taken for its decomposition to 1/8 and 1/10 of initial concentrations are T1/8 and T1/10 respectively. What is the value of T1/8 and T1/10? Into 10 they are asking, and they are also giving the value of log 10 is equal to 2. Log 10, that is log 2 is equal to 0.3. Okay, now let us begin with solving this question. So basically we know what is K. So K of a first order reaction. So what is the K of a first order reaction? K is equal to 1/T log A naught by A. Okay. Log, if you are using, you can't write it like this, 2.303. Okay. Now, in terms of natural logarithm, you can also write kt is equal to ln A naught by A. Okay. Now we will write 1 is for, by assuming 1 T is for T 1/8 is equal to ln, what will happen? Initial concentration is assumed to be 1, and here the value will become 1 divided by 8. So let this equation to be 1. So similarly, you also write it for kt 1/10, which is equal to ln 1/1 divided by 10. So basically, this equation we will assume it to be 2. Okay. Now what we have to do, basically they are asking T1/8 divided by T10. So we will divide equation 1 by equation 2. So we are dividing equation 1 divided by 2. So K and K gets cancelled. So T1/8 divided by T1/10, which is equal to, you will get how much? Ln 8 divided by 10. Okay. On simplification of this, you will get 3 log 2 divided by log 10, so which is equal to 3 into 0.3010 divided by 10, which is once again equal to 0. Not 10, log 10 is equal to 1. Log 10 is equal to 1. So hence you will get 0.9030. So now they are asking in the question the product of this ratio into 10. So hence, what is that? So we know that the product of the ratio T1 by 8 by T1 by 10 is equal to 0.9030 into 10, which is equal to 9 approximately. So approximately we will round it off to 9, and this is what is the answer. So thank you, students. If you have any doubts or queries, you can meet me during the class hours. Thank you so much for your